Welcome back, students. Let's go to determinants of order 3. And we can define the determinant of order 3 like this complicated formula, but it goes kind of like this. Let's see, we have A, B, C, D, E, F, G, H, I like this. And then if you just go principal diagonal direction like this, positive, and if you go the other direction, that's negative. So if you go out of bound, then you just continue on over to A like this. So you see A, B, C, and then A, B, and C would have been here, but that's not really necessary. And then we can consider these diagonals. And that leads to this computation. These are red and these are blue, so to speak. But then again, wow, this is a bit too complicated. Is there any easier way to cancel? And is there any easier way? It'll turn out yes, but please give me a little bit of time before getting to that. We need to get some theoretical parts done, and let's go. All right. We can define determinant function as 3-variable functions with 3 variables. First vector variable, blue. Second vector variable, red. Third vector variable, green. So we have 3 column vectors. Those are 3 variables here. And the property 1 is trilinear. That is, it's linear with respect to the first column. Also linear with respect to the second column. And finally, linear with respect to the third column. There are 3, so it's trilinear. Here we go. Leaving the others the same, we can separate out the linear combination of the first column. Same thing about the second column. Same thing about the third column. You see? Separating out the linear combination for first column, the other 2 stay the same. The middle column, the other 2 stay the same. And the third column, the other 2 stay the same. 3 linearities put together, we call it trilinear. So bilinear for 2, trilinear for 3 by 3. Next property, alternating. So if you switch the order xy to yx, or yz with zy, or xz with zx, in any case, if you switch the order, then you have negative sign. Any switching, negative. Any alternate, then we have negative. A consequence is, if 2 of them are the same, then determinant has to be 0. I don't care what's here, but if I switch these two, x and x, then I'll have to have negative of the same thing, but I don't change anything because there's nothing to change. These 2 are the same. So what number is the same as a negative of itself? It can be only 0. Same thing goes here. Same thing, same. Then we have to have 0. That's an immediate consequence of alternating property. And finally, determinant of identity is 1. Okay. Now, is there any further properties of determinants that you have to know? Well, here's one. Determinant of transpose is the self. Well, let's see. Here is a computational formula for determinant. And does it work for transpose? Here's a scheme. Does it work for transpose? You can check it out by brute force method. It's tedious, but it'll work out. Will it work out for product? Oh boy. To this twice for another 3 by 3 matrix and multiply them and simplify, versus do the matrix multiplication and do this, and then check those and see if those are the same. It's going to be an extremely tedious job, but it'll turn out to be yes. I don't recommend it. It's just too tedious. As for inverse matrix, maybe this is worthy, so I'm going to leave that as an exercise, assuming you're comfortable with this. You don't really have to do this and check it out. It's too tedious. But you have to remember that this is true. Here's an interesting consequence. If the determinant is 0, then of course you cannot have an inverse matrix. It does not make any sense. And also vice versa. Inverse matrix exists and determinant cannot be 0. As a matter of fact, this proof is actually rather significant. But from here you can see a glimpse of it. Finally, here's a big theorem. No, this is not that big. Sorry about that. The big theorem must be yes, this one. Okay, we're gonna do that next time in separate video. I'm not gonna do that for 3 by 3. Alright. Okay, so this is a determinant formula, but then again, this is one way to calculate, but here's another way to calculate the determinant. That is, from 3 by 3 case here, focus upon the first row, and then take the first entry here, A11, and then remove the first row and first column, which this number came from. So what's left? These, and multiply the determinant of the remainder. Okay, that's one. And then take this one, second number from the first row, and then what do you do next? Multiply that and remove this first row, and also this is in second column, so remove the second column as well. So cross this out and cross that out, and what's left will be this A21, A31, A23, A33, these four, and take the determinant of those. Okay, 2 down, 1 more to go. Third number here, A13, and remove this first row and the third column. What's left will be these 4 numbers here. Determinant of that. Plus, minus, plus using the alternating symbol. Did I use the term alternating? And does it have anything to do with the property alternating? You bet. They are closely related. Switch to column and then sign change. Exactly the same thing is going on here. That's how we have this alternating sign. Anyway, this is one way to calculate the same thing. But, okay, by the way, this is the explanation I just gave you. Okay, alright. Take A11, and then from A11, first row, cross those out, first column, cross those out, and what's left will be these 4 numbers. Next we take A22, and then this is A22, right? Cross out the first column where A12 belong to, and this number, that column, cross those out. Cross, cross. What's left will be these 4 numbers. A21, A31, A23, A33. That determinant is over here. And you get the third number from the first row, okay, A13. And then first row, those cross out. Third column, cross those out. And what's left will be these 4 numbers and that determinant over there. With the sign plus, minus, plus alternating and calculate it, that turns out to be a matrix, that turns out to be the same as this expression. if you do some simplification. By the way, that's not the only way to do it. You don't have to do it in the first row here. You can do this through second row if you want to. But first row, first column, that's plus. So I have to come one step down, so alternating sign, so we have to have minus. So minus, plus, minus, minus, plus, minus, A21, A22, A23 in the middle. And how do you get the other numbers? Again, crossing, crossing. So we select this number, A21, so cross out second row, cross out first column. What's left will be these four numbers, determinant of those. And then A22, cross out, what's left will be here. A23, cross out. You can do the same thing to the third row as well. And that's how you can calculate the determinants. I guess some application or example problem is in order. Let's see, do I have some example problems here? Okay, plus, minus, plus, okay. Well, let's create an example problem. Okay, determinant computation problem. Okay, and then let me insert matrix, a 3 by 3 matrix. Okay, negative 2, 4/3, 1, 1, 0, negative 1, 2, 1/3, 3/2. Okay, let's calculate this determinant. One way to do that is to use the first formula. This, or this scheme. Shall we go ahead and do that? Okay, let's go ahead and do that. So multiply these principal 3, that's 0. Okay, all right. Next, these two numbers and that. So 4/3, negative 1 times 2. And then this one and these two numbers. 1, 1, 1/3. I covered these. Principal direction I did. Okay, now subtract this direction. And that's 0 because of 0 right here. And these two numbers and this one. So minus 4/3, 1, and 3/2. So this direction, these two numbers and last one. And this one number and these two numbers. Negative 2 and these two. Negative 2 and negative 1 and 1/3. And this computation is going to be the determinant. Turns out to be negative 5. Okay, that's one way to calculate the determinant. Here's another way to calculate the determinant. Get the row and then first number and the rest. First number, cross, and then rest. Third number, cross, and the rest. You can do things like these, but I think it's better to do it from the second row because of the 0. I like 0. It makes the problem simpler. So let's begin with this. And we begin with plus here. So alternating sign. This is minus. So we have, -1 and the determinant of, so you see, we selected this one, cross this out and those out. So what's left will be 4/3, 1, and then 1/3, 3/2. You see, I have to cross first column and also this row. So 4/3, 1, 1/3, 3/2. 0 times determinant of something, I don't care. And then minus, better to do it this way, minus, so minus plus minus, and then this number is -1. This number is -1. This negative and that negative are different. This is the same as this number, and this negative is, this place is a negative place. Starting from 1, which is plus, minus, plus, minus. As I move one step, we alternate sign from plus, minus, plus, minus. Anyway, here we go, and the determinant. Let's see, we are taking this number, so cross out all the third column where this thing is belong to, and then also second row as well. So what's left will be -2 4/3, and then 2 3/2, and then let's continue our computation. Minus determinant of this, so that's 4/3 times 3/2 minus 1 1/3. So AD minus BC, we just did that, and then minus was there before. And minus, this becomes plus, and then AD minus BC. Minus 2 times 3/2 minus BC. 4/3 times 2. If I calculate this, I'm going to get the determinant. So what's this computation? I'll ask Mathematica to do that, and I'd better have the same value as before, and I didn't get that, which means I made a mistake somewhere, and I can't find it. Okay. Let me stop this recording and let's find out the mistake and prevent. Okay, I found my mistake. I should have removed all these. 4/3 here, this should be 1/3. I wrote this one instead. So this should be 1/3. The others stay the same. Yes, indeed, -5. Same number as before. So, okay. A couple of computations as well. Tedious, but it worked out.